My name's Alexander Ferguson. I'm the founder and CEO of FAC Technology. I'm also a lecturer at Imperial College, and most of our work to date has been focused on making lightweight materials to enable fuel saving in aircraft or to enable the transition to electric vehicles in the automotive sector. We've just bought the latest, greatest Waters GPC SEC system. And we're looking to use that internally as we move to develop bio-derived resin systems such that our products are inherently more sustainable. The performance of our materials is fundamentally linked to the raw chemicals that go in. So we need to really quantify exactly what we're dealing with to start with so that we can ensure we get the best properties of the material out the other end. And for that purpose, that's why we bought this machine. So most of our work to date has been focusing on making very damage-resistant composite materials so that they can be used in aerospace where previously metals have been used. The other thing we're developing at the moment is adhesives for use in the next generation of electric vehicles. So our adhesives are highly thermally conductive but electrically insulating, and this allows people to charge the vehicles much faster by allowing heat to be removed at a greater rate. Well, actually, we're a long-standing user of TA Instruments equipment. They're almost the default within many departments at Imperial College, so it made sense to stick with a system that we're used to. We've had good support to date, and obviously this is the latest, most advanced system out there. So, given the throughput and the ambition of our project, it made sense to stick with a system or a supplier that we know, but also with the latest instrument available.
Recently, my research from over the last 5-6 years has shown that toughness is actually kind of come from a molecular level. So by using this new GPC, we'll be able to actually design materials and formulations to go into components on aircraft and into the automotive industry that are actually designed from the molecular level up. That's what I'm actually really excited about.
Day one of installation, long way to go, still got the training ahead of us, all the application teams. So we see it very much as the start of a partnership going forward, so this is really day one of a multi-year relationship.
So the original APC, our Advanced Polymer Chromatography system, was launched about 5 years ago as a high resolution, low dispersion polymer analysis system. So it does SEC or GPC for polymer molecular weight and polymer size, polydispersity distribution analysis. The system being installed today has had a quaternary solvent manager added to that, hence the name APC QSM. And what that means is you can now do gradient analysis, so you can do analysis of small molecules and polymers on the same system with aggressive solvents, organic solvents that are regularly used in the chemical industry.
So APC has been around for a long time. It's an advanced polymer chromatography system. It gives the highest resolution separations of complex polymer materials, everything from monomers up to very long molecular length styrenes, which might be up into the million mark. The APC QSM system is capable of running gradient separations as well, which gives the capability of looking at additives added to your complex polymer mixture. So it means you have the capability of what used to be two systems in one. The system has been hardened to deal with all the corrosive solvents often associated with APC, but it doesn't have any of the compromises which you'd associate with having a hybrid system. So you've really got the best of both worlds with this system.
So because you can quickly switch between solvents with the solvent select valve, you can quickly develop methods, particularly for unknown or unusual samples in R&D. And the addition of the QSM means that you now can have one system where you can look at your polymers and your small molecules quickly, which is what's needed in chemical and materials R&D these days, with the industry moving towards higher performance, more complex materials.
So the new GPC that we're having installed basically will allow me to, instead of guessing what's in my formulations, I will actually know exactly what is in my formulations. So when I make a formulation, I will know the molecular makeup of that specific system, and so I'll be able to relate actually the polydispersity of that molecular system to the actual in-service performance through the mechanical testing at the coupon level and then up to in-service performance of the actual end product and what it's designed to do. It'll allow me to be much more confident in the set of rules that we develop to build formulations to meet a particular task in composites.
So yes, I'm excited by this new instrument we've got installed today. It's going to help me detecting any impurities into my particles I'm using for my adhesives. And it's going to be able to detect any impurities, moisture, if the particles have been affected by the transportation and so on. Sustainability is really important for me, especially when you're making polymers, because they are absolutely everywhere in our world. And if we want to make the planet sustainable, then you need to make those type of materials sustainable, especially polymers.
Composite materials are finding ever greater and more widespread use because they typically offer reduced energy costs over life, reduced fuel burn over life, and this is increasingly important as we become more and more concerned about the damage we're doing to our environment. However, the materials that are currently used to make composite materials are petrochemicals, and fundamentally that is not a sustainable future for the composites industry. Consequently, it's absolutely critical that we find biologically derived replacement chemicals that we can use in place of petrochemicals.